Okay, so we saw an example of using the print writer, but actually we didn't because I just walked us through it rather than look at this example. This example was in chapter 15, which is the try catch, and it shows using something try with resources. I think we demonstrated that when we clicked on the little warning on NetBeans and it offered to convert it to try with resources, and it gives you something, well, not like that. That doesn't do. Here we go. So you use the word try, but in parentheses, you put a declaration of something that you would like to be cleaned up when it was all done. So we put our output statement, our print writer there. Print writer file out is equal to new print writer. If the try fails, or if it succeeds, then that'll be cleaned up. And what does cleaned up mean? It'll be released, the memory will be released. If it had any files open, it will close it. So that's a much easier way of doing it than putting a finally block down there and using, file out.close and catching any errors it might throw. That one doesn't even have a catch clause at all. If you get an error, I guess you're just out of luck. I would think you would need to put an IO exception there in order to print out. Let's check it out. It's in. Anyways, I'm puzzled as to why that works. So I'm going to go back to our example from Monday, if we still have it. It says, this is just our print writer code. We declare our print writer, then we do a try, and then we do a catch on file not found, and then finally, after all that's done, we try closing the file. Convert to try with resources. Try, and here's what we want it to do. So this is the resource that it's supposed to free once it's done. So it goes ahead and tries that. Well, it opens that as kind of the first line of the resource, kind of like that was there. And then assuming that works, it goes ahead and finishes doing the try. And whether that fails or succeeds, it goes ahead and closes it. It's kind of, yeah. I guess it cleans the syntax up a little bit. If you feel like doing it that way, you can. Okay, so a print writer writes out text files. We're going to look at other ways of writing out data. So far, most of the input has come from the keyboard. However, that's temporary. You display stuff on the screen, you type stuff in, you don't want to do that. You want to be able to save output to a file. Read stuff in from a file. So here's our example of some HTML generation where you ask for the person's file name, you open the file, and you start writing all this stuff. And they opened it as a print writer, just like we did. They kind of saved a step and didn't open it as a file first. They just passed the file name directly to print writer, which is fine. I may stop showing that file object. Then they go through and they open an input file and they read all the data around it and they enclose it in p tags, and then they close out the file with the body and an HTML. So this just opens a text file and creates an HTML file based on it using the scanner and the print writer. We've already done the print writer and the scanner. Reading text from a remote website is like reading text from a file. Comes in as a string of bytes. We can use a scanner to read in data from a website. Let's see if we can get this to work. Honestly, I haven't demoed this one before, but I think this would be cool to get it to work. So let's make a new project. We're going to need java.net.star and java.io.inputStream. Why don't we just declare those as we go? So we do need a scanner in order to ask what we're going to be opening. So scanner sc is equal to new scanner system.in string file name is equal to sc.next. We should have asked, not file name, web name, URL. Let's do URL. And we need to print out a message telling them what we're opening. System.out.println, what address to open. We don't have a scanner yet, so I'm going to add the import for that. Now there's an object called URL and another object called URL connection. So we will follow the example. URL space lowercase URL. URL connection. I'm just going to call this con for connection. Those are two more inputs I need. Imports. Oh, I already had a variable called URL. I'm going to call this SURL for string URL. Went back up there and changed string URL to string SURL. Then we're going to need something called input stream, which is going to be a stream of bytes that we read in. And we want a line number and a max line number. I'm just following their example exactly. We could be copying and pasting at this time. So input stream in not sure about this line number, max line number. I'm just going to leave those off for now. That's the wrong page. So now we got some stuff that we're going to try. URL is equal to new URL, and we're going to open our SURL. So let's try that. Try, parentheses, URL equals to new URL, and we're going to pass in our string. Or not, I've already forgotten. URLs in caps. That's right. Okay. URL in caps. URL is equal to new URL in caps. It's complaining because it wants me to catch this. So I'm just going to right click on this and do add catch clause. If you need to type it in by hand, it's catch malformed URL exception EX. If you saw what I did, then that means users, you can just come over here, click on the code that can throw an error and say add catch clause. And we'll fix this later. It's calling a logger object, and we don't care for that. Now we need to open our connection. So we're going to do con is equal to URL.open connection. And that can also throw an exception. So I'm going to click on that and do add a catch clause for that as well.
That exception is IO exception EX. Is Eclipse making it as easy for you to add these exceptions, or are you having to type them in? Okay. All right. All right, now we're going to read the data in. It's got this line, enter the number of lines to read. I don't want to do that. I want to read the whole thing. So, we're just going to do while webin.hasNext. We're going to read in each line. I don't remember declaring webin. Oh, I called it in. Okay. So in is equal to new scanner, pass a connector to it. I know I'm botching that. Nope, I skipped getting the input stream. Alrighty. So in is equal to connection dot get input stream. Nasty series of things we have to do here. And then now we need a scanner to read from. Scanner webin, or WSC, is equal to new scanner, and pass that connection in. Now we're going to loop. While that scanner has any more data in it, has next, we're going to read a line and we're going to print it out. System.out. Wait, we haven't read it in yet. String line is equal to new, nope, WSC.next line. And then system.out.print line, read, colon, followed by the data we just read. It's amazing how much simpler some things are in Python. We could have done this with 3 lines of code in Python. Alrighty. I seem to have closed my PowerPoint. Really? Really? Then we need to close the stream. Seems like we opened a lot of things to only be closing one of them, but okay. in.close. Let's change these 2 errors to just more generic errors. System.out.println bad URL plus the SURL string. And then system.out.println IO error plus the exception.getMessage. Alright, this may actually work. Let's run it and try to open a website. I'm going to try www.rose.edu. Bad URL. Alright, I didn't prefix it with HTTP colon, etc. And it says this object is moved. It's a header. This document may be found at, and it's got an href tag. Interesting, because if you type in www.rose.edu, we don't see that, as far as I know, www.rose.edu. It just automatically goes to the other one. But if it wants us to tack the S on there, let's see if it will use secure sockets. I'm going to run it once more. Do that. https www.rose.edu. And there we get our file. Got a whole bunch of data in this. We could try to think of something clever to do, like to strip out all the tags and print only the text, or all the URLs for the images and stuff like that. But really, I think that's enough to demonstrate it. We have opened a file and we've pulled out a whole bunch of data out of it. And the way we did that is using, oh boy, we got a lot of exceptions up here. The main one, or imports, was .url, anyways, java.net. Java.net is the biggie that lets you do all that. You open it as a connection, you assign it to a scanner, and you read from it. Let's read from Google. http://www.google.com. Oh, same kind of thing. It's got to have something that forwards us to the website they want us to use. So HTTPS. Alrighty. It doesn't look terribly complicated until you realize that it's about 1,000 characters wide. Good enough. I like Rose's better. We could try to find some simple web page and look at it. Well, I know a really stupid one. Lumland. Here's what Lumland looks like. L-U-M-L-E-N-D. It's just a picture of Urusei Yatsura, a planet, some text. So, run it once more. HTTPS, nope, just http://www.lumland.com. And there we got. If we go and we right-click on this and do View Page Source, what we see should be rather similar to our output. This. There's an HTML tag, a body, a center, a div, a BRBR. It looks like a one-for-one correlation. So what a browser does is it opens a connection to a specific address on a specific socket. And the HTML socket, I forget what it is. It's what it's defaulting to. I'm sure we could open it up another one. And then it reads it in line by line, and it builds something called the document object model, where each thing in here is a separate object that gets displayed on the screen. And then if you're using JavaScript, you can make changes to those objects, which will make changes to what's on the screen. And that's how you make interactive web pages like Amazon, where things light up, or you can add things and move things from lists without going back and hitting the server. Back in the old days of this kind of stuff, you wasn't very interactive. You just got a page of text and a couple of buttons and maybe something you could type in and you would click and it would load it in again. So until JavaScript was invented, then we couldn't have nice interactive pages. Now this one is very old school. All it does is have objects that are created, no buttons or anything. We can see a path to a file, to an image. If Furincan.net ever goes down, then that picture of the anime is going to go away. Alrighty, so that's one way to do it, text. Let us move onward. So, our problem. In object-oriented programming, most data is in an object format rather than text format. And the structure of the objects is user specified or programmer specified. So there's no universal format for storing objects. Each object's variables must be stored separately. Now what we did on Wednesday is we wrote out the data elements and then we recreated our object by reading in line by line. I believe that's what we did. So if you have a student object with a first name and a last name and a student ID, we read in the first name, we read in the last name, we read in the student ID, and then we built a new object with and set those. But we could make it so that an entire object was written out with one call. All you've got to do with that is we have to use this interface called serializable. So let's make a new project. I don't see why we need to keep doing the web page each time. Or I guess we could tack it on but change the name of it from main or to something else. It'd be easiest just to make a new one. Let's just make a class that has one object in it. Class, student. All a student has is a name, for now. String name is equal to default. But we want this to be serializable, meaning that we want it to be written out to an object file or read in from an object file. So we got to do implements serializable. I hope I spelled it right. I'll know when I click on this and it says import. Okay. Now that's really all we have to do because the serializable interface adds whatever methods are necessary for this thing really to be serializable. What does serializable mean? Converted to a byte stream so that it could be written out to a file or converted from a byte stream back into this data. That way we don't have to do it ourselves. So to get that to work, we need a file output stream and an object output stream to write to. So what we're going to do is we're going to create a new object output stream, and from that we're going to create the file output stream and then use that to feed the object output stream. I guess we could ask them for the file name. System.out.println save to what file name? Scanner SC is equal to new scanner system.in. Add import. So file output stream FOS object output stream OOS. Now let's add our try so we can start doing stuff. FOS is equal to new file output stream. Oh, we never actually called the scanner. File name. Go back up here, write it where we declare the scanner, and do string file name is equal to sc dot next line. This one, didn't mean to do that, throws a file not found exception. So I'm going to add a catch clause for that. Catch file not found exception. And I'm going to fix the error for that later, so I'm just going to delete that. Oh, why not right now? System.out.println file not found. Now when you're creating a new file, why could a file not be found? It shouldn't be there. But that means that the path is bad or something like that. It's a pretty generic error. Plus file name. All right, now we need to create our object output stream based on our file output stream. OOS is equal to object output stream, parentheses FOS. At that point, we have something we can write our data to in the form of objects. Create method object output stream. What have I done? I don't know, but it's an error. I'm not getting it. Oh, new. I forgot the new keyword. And that one throws an exception too. It can throw an IO exception just like all the others. So now we add catch IO exception. We may as well print that error out. System.out.println IO exception plus ex.getMessage. And then we're going to close it. Well, we haven't written anything to it yet. So, here, after we've opened it, object output stream OOS dot. Now check out all the different write methods. You could write just an int, you could write a character, you could write fields, or you can write an entire object. Now there's a danger to writing out an entire object, which is that if the class that you're writing out, you change the format of it, then your data is no longer valid. You've written files, but you can't read them back in. So there could be an advantage to reading them in byte by byte, or character by character, or whatever, and reconstructing the data yourself, like we just did with a text file. But we want to see how awesome this is. Dot write object, parentheses, and we don't have a student yet, so we may as well create a student. I think I made my student named lowercase s, so I'm going to go back and fix that. Student now has an uppercase S. So that I can go back down here and do student S1 is equal to new student. Change his name. S1.name is equal to Joe Bob. And write that student out with write object. S1. We can write out more than one object. Make another student. Student st is equal to new student. S2.name. Beth Smith. Write that one out. OOS.write object. OOS. Nope. S2. Then let's close our file. OOS.close. FOS.close. And let's see if that works. It's not going to print anything if it works. I'm going to call it txt just so that I can find the file easily and open it with Notepad, but it's not going to be very readable. Well, supposedly it worked. We should have added some print messages saying it was successful. If I go and do open file, go into my NetBeans directory, find my most recent one. 23. I find t.txt. I open it. It says contains binary data. That means it's no longer ASCII data. It's no longer text. Are you sure you want to open it in the text editor? Yeah, why not? Okay, I can't even see anything in it. It looks like garbage. So that's not too cool. Maybe I could open it with hexed.it, hex edit, do open file, documents, NetBeans projects, Java application 23, find t.txt, and there's my data right there. If you can see this, it's got some object information about it. It says that this is part of the student class. You see Java application 23.student, so it knows what kind of object that is. It uses that information when it gets read back in. And the data in the object consists of a string, which we see here. Doesn't have the, yeah, it even tells us the name of that one. And then it's actually got some data. And then it's got Beth Smith as well. Reading this data in, pretty much the opposite, but the same sequence that we just did. So let's scroll down a little bit. Oh, let's run this again and create a bad file name, just for fun. Save to what file name? Well, I'm going to save to the ZZ drive. zz.t.txt. Well, what do you know? I wonder what. How interesting. Let's add a print message as well, saying that it finally worked. So here I'm going to put, after those closes, system.out.println file saved. Now I really wonder where it saved that. Did it save that in our root directory there? It saved it in, yeah, it's right there. Huh, what do you know? Okay, now we, instead of object output stream, we need object input stream. And instead of a file output stream, we need file input stream. So let's ask them again for the file name. Println read from what file name. It'd be even cooler if we made a menu that said, you know, 1 to write, 2 to read, 3 to quit, something like that. File name is equal to sc.next line. Let's try opening that. We need our file input stream, FIS. I'm just going to leave that alone. And then object input stream. This is kind of implying that there's more than one kind of file input stream. Otherwise, why would it be a two-stepper like this? But anyways, we'll go with it. OIS, object input stream. We need our try-catch blocks. FIS is equal to file dot, is equal to new file input stream. Pass our file name into it. OIS is equal to new object input stream. Pass that file into it, file input stream into it. We're getting all sorts of little errors that we need to correct. So I'm going to add an import for java.io.fileinputStream. I could probably shorten that just by coming up here and doing import java.io.star. Then I could probably get rid of all of these. Let's give that a shot. Yeah, that fixed a lot of them. So we need to add a file not found exception, just like we had up here. I'm just going to go and copy that print statement. You can copy the whole catch for it. And we need to add a catch clause for IO exception, the same two that we had to have up here. So we could have just copied all of those text clauses, all those catches, pasted them in. So object O is equal to OIS dot read object. Notice I'm reading it in as a generic object. That can throw an exception as well. Then I'm going to cast it to our favorite kind of object. Student. I could call them S1 and S2 again because that was inside the other code's context. S1 is equal to student O. I will add the import for that class not found exception. That's what you get if you change the class or it can't find the class when you're reading it in. If we went to another app and we tried to read that object but it had no idea what a student was, it would generate this error. So class not found exception, system.out.println. Oops. Input error. That's pretty vague. And we had two students in a row, so let's read the next one in as well. O is equal to OIS.read object. Add in student. S2 is equal to student O. Now I'm going to type this. You don't necessarily have to do this. These two could be shortened into one line. You could do this. Student S3, we don't have 3 students, so this is going to be an error, is equal to parentheses student OIS.read object. Let's print out our students as we've read them though. So I'm going to add a system.out.println s1.name and then do the same thing, system.out.println s2.name. It ought to blow up at that point because there's no third object. So save to what file name? t.txt. Read from what file name? t.txt. IO exception null. It tried to read that third object in, but there wasn't a third object. So there needs to be a way of checking to make sure that there's any more data saved in that file. You could just put it in a loop and keep doing it until you got an IO exception. Honestly, I don't remember how to do that. Let's just type in OIS dot and see if there's anything that tells us that there's some upcoming data. No, there's not. Well, do you know? Google it up. How to tell if there is more data in an object input stream. We're not going to mess with that. My immediate fix would be to do this, to not print out an error message once we hit the end of the file, just to stop going. Now we have a problem here. We haven't closed the file yet. And if we're going to use an exception as our way out of it, then we would need to close that stuff in a finally block. So we have to make a few changes. Come up here and do this. FIS is equal to null. OIS is equal to null. Wait. And then go and add, comment out this IO exception, and we're just going to put the comment and say, we hope this means we hit the end of the file. And then we need a finally block. If OIS is not equal to null, call OIS.close. If FIS not equal to null, FIS.close. Take out the parentheses on finally. I forgot that you don't put parentheses on finally. It's complaining. It wants us to try and catch exceptions here. So, fine. Put a try in front of all that. And then just catch everything. Exception.ex. Absolutely everything. We're just going to say, if we got an error closing stuff, we don't really care. Because if we're getting an error closing it, it means it wasn't open to begin with. So that's the end of our finally. This is okay. If we get an error closing, it means it's not open in the first place. This is the kind of thing where using a try with resources would be a good idea, because it would clean up and close that file automatically rather than us having to add it. If I was content to only read in a specified number of items rather than to read in a whole string of objects, I wouldn't have used the IO exception as our indicator that we hit the end of the file. I would have just read in 2 objects and been done with it. Write out to txt, read in from txt, and it read our 2 students in. We could store all of our students in an array list and then write them out in one fell swoop. So let's do that. Array list student, I'm going to call it SL for student list, is equal to new array list diamonds parentheses. Let's create some students and add them. Student S1 is equal to new student. Here's about the time where I wish we'd made a constructor. S1.name is equal to Bob. Student S2 is equal to new student. S2.name is equal to Jack. Student S3 is equal to new student. S3's dot name is Jill. Add all those 3 to our array list. SL.add S1, S2, and S3. Now this is going to seem kind of repetitive, because to do all this we have to do the same thing we did up here, which is to open the file, write it out, you know. I'm just going to copy it. So go up to here grab all of this stuff from the try. Well, we should ask them what file name. Anyways, grab everything from the try all the way down to the bottom of the catch of the write code, not the input, file input stream, object input stream, but from the output one, just to save ourselves from typing it in again. We ought to type it in again, but we only have 10 more minutes in the class. You know what, we really ought to. We're gonna, I can't decide. Let's do it. Try, I'm going to type it in by hand. FOS is equal to new file output stream file name. We should have asked them for the file name. OOS is equal to new object output stream. Now we have an object string. Let's write our object out. OOS.write object SL. Close OOS. Close FOS. Now we need to add our catches. Wait, I'm not going to type. This would be a really good time to go cut and paste. That's really tedious, adding the catches. I am going to go and copy the catches from our first file writing code. There's just two of them. File not found and IO exception. So I'm going to copy those two, scroll back down here, and add them to the new one. I forgot to pass in FOS as a parameter to OOS. Let's tell them that the file was written. System.out.println file written plus file name. And now let's read it back in. File input stream is equal to new file input stream, file name. Object input stream is equal to new object input stream, FIS. Part of me is wondering if we could skip that first step and just plug the file name in there. But anyways, I forgot to put this in a try catch, so try this stuff. We have our object. Let's create a new array list and read it in. Array list of student SL2. O is equal to OIS dot read object, and let's cast it to an array list. SL2 is equal to array list of students. Now let's close OIS. No, wait, OIS.close. FIS.close. It's wanting all of our try catches. Guess I'll do them. We need a file not found exception. We need an IO exception. Oh, this should have been object O. Sorry about that. I forgot that we hadn't declared that outside of, it's out of scope. And then class not found. So we have three more exceptions. File not found. We could have just copied and pasted them. Print line, file not found, plus the file name. This time, let's actually report the I/O exception, because since we're only writing one object out, it's a real problem if we can't read it back in. System.out.println I/O exception plus ex.getMessage. And lastly, class not found is a real serious problem. System.out.println IO error, or IO class error, something like that. Let's just frustrate the user and say that. Here, after we've closed the two files, or maybe even before, let's print out all the objects in the student class. For every student S in SL2, system.out.println red plus student.name. Alrighty, I may need to scroll up and down for y'all to get everything I typed. But if it worked for you, what you see is that with one read statement, we got 3 students in. The way we were able to do that is we stored all the students in an array list, and then we wrote that object out in one fell swoop right here. We called one write object. It wrote it out to every student that was stored in the list. And then here we called read object. We read in one object, which was an array list of students, and so we got all the data with one read. So that's a really convenient way of sending data across the internet or saving it to a file or whatever, using object output streams and object input streams. And object output streams and input streams don't only have to be files, they can be sockets for internet connections. Alrighty guys, that's about enough of that. I want to mention projects. If you do a project, you can skip the final. So I need to bring up what the projects are so you can pick one. So here are the 3 project ideas. This explains a lot about it, but it makes it look more interesting and complicated than it really is. It makes it look like you can write a graphical user interface that does this. But say you have a calculator where the first 4 bits of a binary number are the vertical lines, and the last 4 bits of a binary number are the horizontal lines. And if you press, for example, a 7, it lights up that line, sets it to a 1, and it lights up that line, which sets that to a 1. And we could turn that into a hexadecimal value. So what this one needs to do is you're going to type in a series of numbers that represent those hexadecimal values. Whatever that one is, 1, 2, 4, 8, 16, 32, 64, 128, so that's 130. I don't know if I added that up right or not. But you get the idea. A 2 would be, second one with the last one, and equal is the third one and the last one. The multiplication is the last one and then the first one, which would be a 1. So you just figure out, you let the user type in a series of values that represent the integer values generated by that keypad. So please enter a series of integers. -1 will stop the input. You type in a number, you type in another number, you type in another number, you type in another number. If this works, 7, that was a 7. The 18 is a plus. The 132 is a 4. Another 132 is another 4. 11 isn't anything. It's not one of the 16 possible values, so we disregard it. And then the 15 is the equal sign. And once you got the equal sign all fixed, well, they type in -1 as the end of their input stream, and then you calculate. whatever that first piece of data is, followed by the operation, followed by the second piece of data, and you generate the answer. And the rest is more explanation about it. So that's one project idea. Caesar Cipher. This is the fun one that a lot of people choose doing. The way it's supposed to work is, if you know what a Caesar cipher is, it's where you shift things in the alphabet. If you shift everything by 1, A's become B's. B's become C's. C's become D's. And so far. So, if they type in A, B, C, D, E, F, the quick brown fox, then all the A's are going to become B's. All the B's, like in brown, are going to become C's. All the C's, well, there's one right there, become D's, and so on. So that's what's known as Caesar cipher. There are other ones where the sequence is randomly generated rather than just being a 1, 2, or 3, because this is incredibly easy for a computer to break. You know, back in Roman times, it may have been, the height of security. So anyways, this one is going to generate 94 different permutations of a string that you put in. If you put in a string that's already been enciphered, it will decipher it. But it's going to display 94 different options, 94 different versions of it. The rest of this is all explanation of how to do it. What it does is it does it not based on just the alphabet of uppercase letters that the Romans used, but it does it on ASCII values. So it shifts the last ASCII value back over to the first ASCII value or whatever. So that one's kind of fun. And then I give you a string that I want you to decrypt. You type in that certain string, you let it run through all 94 permutations. One of them will have some English in it, and you go, okay, I decrypted the string. That's the second project. Selection sort versus bubble sort. Compare the number of comparisons and swaps by two sorting arrays, by two sorting algorithms. I don't want you to go out to the internet and copy some bubble sort and selection sort code found on the internet. I want you to implement your own based on these algorithms that I provide you. This is actually written in Python code, but it's really easy to convert this Python code into Java. I even give you little comments there. Write a for loop in order to do this specific line of Python and whatever. So what you're going to do is you're going to implement these sorting algorithms, and then you're going to modify them so that it counts the number of swaps and the number of whatever the other piece of data I wanted us to figure out. The number of comparisons and the number of swaps. So implementing the sorting algorithm should be pretty easy. And then making those modifications to it, maybe slightly less so, maybe not. So just generate 10,000 randomly numbers, make a copy of that array, call it with sort method 1, call it with sort method 2, and then print out the number of swaps and comparisons that each one took. That's the third project idea. You don't have to do a project at all, but if you do, you can skip the final. So the Caesar cipher you might be able to knock out really quickly. I even give you sample code. I made that one too easy. I'd rather not everybody do the Caesar cipher though. So think about it. Let me know if you're going to do a project. If you say you're going to do one and then you don't, I'm not going to yell at you, but I'm just curious. All right, guys, let's make a Dropbox. And I'll post a Dropbox folder with all those project ideas in it.